Hello and welcome to another set of examples for Chapter 1, CSE 259, Natural Deductions. In this set of examples, we will look specifically at using the OR and the implication. So if you see the formulas on the slide, uh, you see the introduction formula for implication, which is assuming phi. If you come to a conclusion psi, then phi implies psi. The elimination formula is given phi is true and phi implies psi is true. The natural truth table would tell you that psi is true. So this is the elimination formula of implication. Similarly, the introduction formulas for disjunction, that is if phi is true, then phi or psi is true. Or if psi is true, then phi or psi is true. And the elimination formula for disjunction. So given phi or psi is true, assuming phi is true, you come to a conclusion chi. Similarly, assuming psi is true, you come to the same conclusion chi, then we can say the formula chi is true. Now you need to remember that this always come from the truth table of implication and disjunction. Now, given these formulas, let's look at how to solve this example over here, where P implies Q and R implies S is given to us. So in the premise, we have two paths which are there. So the first premise is P implies Q. And the second premise is R implies S. Now, given this, we need to prove that P or R implies Q or S. So in case of an implication, we need to prove an implication. So the formula of introduction of implication says that you need to assume a phi. So if you look at this over here, this is a phi and this is a psi. So the first part of it, let me assume P or R, right? So this is my assumption. Now given P or R, I am given P or R, then assuming P is true, I need to come to a conclusion, and assuming R is true, I need to come to a conclusion that is based on the elimination rule of R. So I make another assumption over here, which is P. Now given P is true, from 1, we can say Q is true. P is true and P implies Q is true. So I get from the elimination rule, using 4, 1, I get Q is true. Now, given Q is true, I can use the introduction formula and say Q or S is true. So this is the introduction formula. This is the disjunction introduction formula 1 using 5. Now, this is one part of it. Now, the second part of it, I will write it on the side over here and do it quickly. So given now the other part of it which needs to be true is R, assume R, then from 2 and 7, I can say S is true. This is elimination from 7, 2. So from this, I can say Q or S. I2 of 8. Now, given this, I assumed P and came to Q or S, assumed R and came to Q or S. So I can say from these two that Q or S is true from the or elimination of 3, 4 to 6, 7 to 9. So this is one thing. Now from this, I can conclude that P or R implies Q or S from introduction of implication 3 to 10. So this is how you use the formulas of implication and disjunction to prove the validity of a formula. Now let's assume and let's look at another example. This is a much simpler one in case of disjunction. Uh, this is more about a conjunction, which is simpler for the formulas. You can look at the notes provided by in your canvas and a few other examples. All I need to do is here my premise is P or Q. So this is my premise. If I assume R, then from 1 and 2, I can say P or Q and R. So this is and introduction from 1 comma 2. So from this I get R implies P or Q and R. This is the introduction for implication 2 to 3. So this is more about understanding the implication formula and the disjunction, conjunction formula. And so this is a very simple example for you to look at. Now let's look at another little more complex example, which is this. So you have P and Q or P and R, then we can conclude P and Q or R is true. Okay. So here again, we have a lot to unpack in this. So the premise here is P and Q or P and R is the premise. So first from this, I will take P and Q as my assumption. Now from this, I have two possibilities. That is P is true, that is an elimination of keeping 1 from 2, and the other is Q, an elimination 2 from 2. So given this, now I can say Q or R from disjunction introduction 4. Now from 3 and 5, I can say P and Q or R. This is an introduction from 3 comma 5. So this is one part of it. The second part of it is, I assume the second part, which is P and R. Again, from this assumption, I get P. So this is assumed. I get P elimination 1 of 7. Now, please note here that even though I got P to be true in the previous assumption box over here, I still do this part of it again in this box because the two are two different assumptions. So I need to prove it all the way in both these assumptions. So this gives me the other one is R, which is again an elimination 2 of 7. So continuing here, pardon me for this. So I can again say Q or R, this is introduction 2 from 9. So this gives me P and Q or R from and introduction using 8 comma 10. And that is the second assumption. From 6 and 11, I can conclude P and Q or R by using the OR elimination rule. So what all am I using? 1, comma, 2 to 6, comma, 7 to 11. Hence, I've proved this. So this is how you go about doing your uh, and or uh, interruption and eliminations, or proving your natural deductions for the formulas. For further examples, please have a look at textbook. Try to solve as many examples from the back of the book. Uh, and if you have still further doubts, please reach out to us. Yeah. Thank you.